Hi everyone. So my name is Srishti and I'm going to be presenting from the Multilingual Reward Model team. So next slide. Let's talk about LLMs. How do we train LLMs? We take a lot of internet data, we take a model, throw that data on the model, and then ask the model to just learn the language. But this is problematic for the reason that the internet data consists of a lot of negative and toxic data, and we don't want our model to learn that because we want to make it safe for the public to consume. Here kicks in RLHF as one of the techniques to make these models safe for the humans to consume. When I talk about RLHF, I can't really skip reward models for the reasons that these reward models are the ones that we rely on. Like these are the oracle on which we rely on to get the signal of whether an answer to a response, is it safe or is it unsafe? So that's how important reward models are to the RLHF pipeline. Now, to date, at least according to my knowledge, there is no extensive work that benchmarks how these reward models perform for the purpose that they are meant for. Reward bench is one work, but it's only for the English language. Here we kick in. We take one step further and we thoroughly evaluate a lot of reward models for the multilingual setting for a suite of total 23 languages. Next slide. So what we do is that, next slide, Madden, please. Yeah, so what we do is that we take the original reward bench dataset that consists of triples. Now, triples are like a prompt, a safe response or a preferred response, and a non-preferred response. This data set is totally in English, but we want to see the capabilities of reward models for non-English languages as well. So we take this data set, use the NLLB model, which is targeted to translation, and translate this data set into a suite of total 23 languages, and then evaluate 16 proprietary and open source reward models on these 23 data sets. And next slide shows the numbers that we have. So a lot of numbers, I'm not going to explain each one of them, but we can clearly see that some models are very bad at all of the languages. Some models are good at some languages while bad at the others. Some models are a mix of these two. But yeah, what the signal that we get from here is that we really need to pay attention to the capabilities of the reward models as far as all of the languages, including English, non-English, like all of the languages are concerned. Next slide. This is actually a pretty interesting slide because this shows that how does the accuracy score of these reward models change when we shift from English to some non-English language. So what we've done over here is that we've taken an average of those 23 languages. But what we can see is that even for our best performing model, there is a significant drop of around 7 to 8% from English to other non-English languages. And this drop is most significant for the reasoning category and the least significant for the safety category. So yeah, and next slide. So on the next slide, what we now wanted to focus on is that since we used a machine learning model itself to translate the data set from English to non-English languages, is it the translation quality that's really getting reflected in these numbers that we have for all the reward models? So it's kind of a confounded property and we wanted to check this. So we took a better translator. We took the Google Translate API, which is actually pretty nice. And then we translate the English data set into three different languages, Hindi, Indonesian, and traditional Chinese using the Google Translate API. And here are the numbers. So what we see is that there is actually some improvement from the NLLB translated dataset to the Google Translate translated dataset. And this number is the most significant for traditional Chinese across all categories, which is chat, safety, chat hard, and reasoning. And the reason for this is actually known. The reason is that the NLLB model isn't really good at translating to CJK, which is Chinese, Japanese, and Korean. And that is what we also find. So next slide. It shows our third finding, which is also an interesting experiment that we did. So let's say I'm a user and I have a question which says, what do you do? The response says, I'm a doctor, or I'm an engineer, I'm a teacher, or whatever profession. So these reward models should really score each of these pairs equally and shouldn't really show a bias towards any particular profession, but they actually do show a bias, which is very clearly apparent here. Red ones are low scores and blue ones are higher scores. So yeah, this is also one experiment that we did. Now, another very important direction of our work is that while we translated the data sets from English to some other language, did the gold preference labels change? maybe due to cultural reasons or some other reasons. So what we did is that we set up human evals for 2 languages as of now, Indonesian and Spanish, and then we see how much are the reward bench labels in sync with the human labels, humans that speak Indonesian and Spanish. And we find out that the percentage is more for Spanish and less for Indonesian. And then we also evaluated a reward model, which is Llama 3.18 billion. Like, it's a generative model. We use it as LLM as a judge and see how well it is in sync with the human given label. Those numbers are also over here. And as expected, they are not so good. So next slide. This is our dataset number 2. This dataset looks like a source sentence in English, a preferred translation in some other language, and a non-preferred translation in that same language. So it is a mix of English plus some non-English language dataset. And then we evaluate our reward models on these dataset to get a sense of how well these models are able to evaluate, this translation kind of a thing. So the numbers are over here. These look decent, at least to me. So, and this is an ongoing experiment, by the way. It's not completed yet, and we are doing this
I personally think if someone asked to play a drill, she'd play a drill. The technique.
Sorry, Shrishti, you can continue.
Okay, sure. Yeah, and we are continuing this experiment for a whole lot of reward models. So next slide. Yeah, so to wrap things up, the final thoughts from my side are that we really need to pay a lot of attention to these reward models as far as the multilingual setting is concerned, so as to make sure that the models that we are aligning using these reward models are safe for the global population to consume, for everyone to consume, and not just for the English-speaking population. And so, yeah, that's it. And our data set and code, everything is open source, available online. Feel free to check it out. What's in progress is that we are really working hard on improving the quality of translations. We are also setting up human evals to check for preference inversion and preference preservation. And yeah, that's it. Our appendix is also attached. Feel free to check it. Thank you.